Named after American astronomer Edwin Hubble, the Hubble Space Telescope is one of NASA's great observatories and one of the largest space telescopes that sits in low Earth orbit, approximately 350 miles above the Earth's surface. It was launched by the Space Shuttle Discovery in April 24, 1990, and it is still in operation. Hubble was built to escape Earth's light-altering atmosphere and provide astronomers with an unobstructed view of the universe. For 30 years, Hubble has recorded some of the finest images of deep space, which have led to many breakthroughs in cosmology, astronomy, and astrophysics. The Hubble Space Telescope is one of the most productive scientific instruments ever built. Since its launch in 1990, it has made more than 1.5 million observations of more than 43,500 celestial objects, generating over 153 terabytes of data. More than 15,000 scientific papers have been published based on the data collected by Hubble. Hubble has contributed to many important scientific discoveries which have changed what was previously known about the universe. The age of our universe, the formation of galaxies and planets, the study of black holes, the universe rate of expansion, and the discovery of planets orbiting stars like our Sun with atmospheres similar to ours have all been significant finds by Hubble. The Hubble telescope had to meet many operational and design requirements from scientists, engineers, and regulatory agencies. The telescope had to capture images across the entire optical spectrum and store enough power from solar panels for operation while in Earth's shadow. It required the ability to change direction of observations without any onboard rocketry. In order for Hubble to reach Earth's orbit, engineers had to consider the payload limitation of then existing Space Shuttle program. In addition, Hubble Space Telescope would need to be serviced in space for maintenance, repair, and replacement of outdated equipment. NASA selected several space partners to assist in Hubble's design and construction. The Space Flight Center in Huntsville, Alabama, led the design, development, and building of Hubble. The optical telescope assembly and fine guidance sensors were sourced to Hughes Dunbury Optical Systems, while scientific instruments design and ground control systems were developed by Goddard Space Flight Center in Greenbelt, Maryland. Lockheed Martin constructed the outer structure, support systems module, and coordinated systems integration and final assembly. In total, several universities and organizations across 21 states and 12 countries contributed to Hubble's development. Starting from the initial design to the final assembly, all teams had to ensure that their individual components will fit together and collectively work as a single system, which will be known as the Hubble telescope. This came out at a total cost of $4.7 billion, more than $4.2 billion over the original estimate. Hubble's power is not magnification, but the ability for it to collect more light than human eye can capture on its own. The primary mirror is 2.4 meters in diameter, much smaller than the terrestrial-based telescopes, which can be as much as 100 meters in diameter. However, because of its location outside of Earth's atmosphere, it has extremely high clarity. Each of the scientific instruments on board Hubble telescope collects data to study different aspects of the universe. Instrumentations include wide field camera, cosmic origin spectrograph, advanced camera for surveys, space telescope imaging spectrograph, near-infrared camera, and multi-object spectrograph and fine guidance sensors. The data that Hubble collects is transferred from tracking and relay satellites to a ground station in White Sands, New Mexico, where it is then transferred to Goddard Space Flight Center in Greenbelt, Maryland, and finally to the Space Telescope Science Institute in Baltimore, Maryland, where it is processed and made available to scientists. In this regard, Hubble, which is a complex system on its own accord, continues to depend upon other support systems to fulfill its purpose.
The conclusion we've come to from that is that there's a significant spherical aberration appears to be present in the optics, in the optical telescope system optics.
Shortly after launch, it was discovered that Hubble's primary mirror had a small defect which altered the reflection of the light to the scientific instruments, causing a spherical aberration. After almost a year of problem solving, NASA launched the first servicing mission aboard the Space Shuttle Endeavour to install a new wide-field camera with corrective optics and a series of small mirrors known as Corrective Optics Space Telescope Axial Replacement, or COSTAR, to capture the reflected light and properly direct it to the instruments. The space mission validated one of Hubble's original requirements, that it could be serviced in space. Following the initial servicing mission to correct the mirror defect, Hubble has had 4 additional servicing missions. From February 11 to 21, 1997, Service Mission 2 was conducted to install new instruments to increase Hubble's wavelength range. Servicing Mission 3, from December 19 to December 27, 1999, was used to correct a failed gyroscope that sent telescope into a safe mode until it could be repaired. Servicing Mission 4, March 1 to 12, 2002, was conducted to replace the solar panels and install an advanced camera for surveys which replaced Hubble's last original scientific instrument. Servicing Mission 5, May 11 to 24, 2009, was the final mission to Hubble. Astronauts from Space Shuttle Atlantis installed a cosmic origin spectrograph and a new wide-field camera and revived the Space Telescope imaging spectrograph and advanced camera for surveys in the first ever in-orbit repair mission. Other components were also replaced to extend the life of Hubble until its replacement's James Webb Telescope is brought online.